In this video, we're going to work on some problems from lesson 6.1. Our first learning target that we are going to cover is I can use perpendicular bisectors to find measures. And so this is on page 166 in your student journal. I would turn there so you can see this theorem in front of you. This is the perpendicular bisector theorem. So in our exploration, we discovered that if a point lies on the perpendicular bisector of a segment, then it is equidistant, which means the same distance away from the endpoints of the segment. So in this particular picture here, point C lies on the perpendicular bisector of line segment AB, which means that then these two line segments, the blue and the purple, must be congruent. Those lengths must be the same. So we're going to go ahead and try some of these. This is going to be on page 168 in your student journal. So please turn there with me. This is on page 168. We're going to do numbers 1 through 3. In exercises 1 through 3, find the indicated measure. Explain your reasoning. In number 1, we need to find the length of AB. So I'm just going to highlight the length of the segment we need to find. Our goal is to find the length of this orange line segment. I notice that point A is on the perpendicular bisector of line segment BC. And I know that because this is a right angle and these two segments are equal. Well, from the perpendicular bisector theorem, we know that if point A is on the perpendicular bisector, these two lengths are congruent. So if AC has a length of 9, the length of line segment AB is also 9. Number 2, we need to find the length of EG. We need to find the length of this line segment. Well, we can see that point F is the same distance away from point G and point E because they both have a length of 7 here. These lengths are the same. What that means then is point F must be on the perpendicular bisector of line segment GE. So if it's on the perpendicular bisector, this length, the length of segment EH, must be equal to the length of segment GH. So if EH has a length of 3, line segment GH also has a length of 3. Therefore, the length of EG must be equal to 3 plus 3. In number 3, our job is to find the length of SU, line segment SU. So before we can actually find a length, notice I have a variable, which means I'm going to have to set up an equation. First, I have to figure out what do I know is true. Notice R is 10 units away from point S and from point T. These lengths are congruent. They're the same. So what that means is R must be on the perpendicular bisector of line segment ST. This means that the length of TU must be equal to the length of SU. And so what we can do is we can set up an equation that sets these two lengths equal to each other. 2x plus 2 must be equal to 3x. We're going to go ahead and solve for x. I'm going to subtract 2 on both sides of my equation. And I get that x is equal to 2. Now I'm not done. Remember, I need to find the length of SU. So now that I have x is equal to 2, I can plug 2 in for x to calculate that length. So the length of line segment SU is equal to 2 times 2 is 4, plus 2 more is 6. Our next learning target, we're going to be using angle bisectors to find measures. So now we're thinking about angle bisectors. The angle bisector theorem is on page 167 in your student journal. I would turn there. We discovered in the exploration that if a point lies on the bisector of an angle, then it is equidistant or an equal distance from the two sides of the angle. So in this picture here, point D lies on this angle bisector, and therefore these two segments, my green and my blue segments, must be equal. They're congruent. So we're going to practice the angle bisector theorem. We're going to go and do 5 through 7 on page 168 in your student journal. So go ahead and turn there, please. In exercises 5 through 7, find the indicated angle measure, or find the indicated measure. All right, in number 5, we need to find the measure of angle CAB. I want to find the measure of angle CAB. That's going to be this orange angle here. I notice that point D is an equal distance away from C and B. Well, that must mean then that point D is on the angle bisector of angle CAB. If it's on the angle bisector, this ray here bisects angle CAB. So if angle DAB is 20 degrees, the measure of angle CAD must also be 20 degrees. Therefore, to find the measure of angle CAB, my orange angle, I need to add these two smaller angles together. The measure of angle CAB is equal to 20 degrees plus 20 degrees, which is 40 degrees. In number 6, we need to find the length of DC. That is this length here. Notice that point D lies on the angle bisector of angle CAB, and I know it does because these two smaller angles are equal. Therefore, if the distance from point D to B is 5, the distance from point D to C must also be 5. Number 7, we need to find the length of line segment BD. I notice, because I see some variables, that I'm going to have to set up an equation. Point D lies on the angle bisector of angle BAC. I know that because these two smaller angles are congruent. They each have one arc. Therefore, this distance, the length of DB, must be equal or congruent to the length of DC. This allows me to set up an equation. 3x plus 1 must be equal to 5x minus 1. Let's solve for x. And I get that x is equal to 1. Now be careful, I have to actually go back and find this length. So now I'm ready to substitute 1 in for x. So the length of BD is equal to 3 times 1 is 3, plus 1 is 4.